but they're wrong. Today I'm just an aluminum can, but one day I could be a stadium.
For our last interview, we have Vincent Fredericks, whose presentation is titled Staining, Scanning, and Producing Three-Dimensional Images of Unicellular Organisms Utilizing Z-Starch Confocal Microscopy. Vince, what exactly does that mean?
This means that I found out a way to use a very fancy microscope to produce three-dimensional organisms or three-dimensional models using those pictures from that microscope.
Mm-hmm. And so what are we looking at here? You said these are blown-up versions of single-celled organisms?
That's right.
Okay, so what are we looking at? Which ones are these right here?
So what we're looking at is this is a, it's called a filamentous algae, and it looks like a filament, that's why. And we have a full model of the membrane. For this guy, this is the full organism.
Okay.
And this allows us to provide a more concrete example for abstract concepts. You can't really see these with the naked eye. So how can we blow these up to be able to manipulate them in our hands and actually view them? So I wanted to create a way for students and researchers to be able to create a more concrete example of these specimens.
So now what are these ones? Are these, those are different?
These are colonial algae cells. So these guys, what they do is they're called Pediastrium. That's their scientific taxonomic name. And they actually grow in a disc, and they will slowly start to spiral out as they continue to grow.
Okay. And so your presentation this morning was on the printing of these and getting these designs, the models out?
Correct. It was on the staining, the mounting, the scanning, and the printing. It was a 4-step process.
Okay, and now walk me through that process a little bit. What is the first thing you do? You said scanning. So what do you do when you're starting that?
So when I scan these, we need to have this laser, this microscope produces a laser that will excite the pigments in these organisms. So we have to actually stain these organisms to provide some sort of pigment to.
Is that so that you can see them?
Exactly.
And then, so after the scanning or the staining process, then you scan them into a computer?
Yep. So this microscope is fully integrated into a computer, and then we can collect those images.
Okay. And then with those images, you then go on to do what?
We take these images, and each image is a slice. Think of it like a slice. So we are slowly taking an additional slice as we go deeper and deeper into that organism.
Okay.
We take all of these pictures, and we just stack them on top of one another.
So you're almost building, these, you really are building models of these organisms.
Correct.
Okay. Why?
Why? So the reason why I did this is I'm an adolescent education major. And when high school students first encounter things such as cells, they do not fully comprehend what a cell is. We only see it in a textbook or a two-dimensional image. That being said, we can take these abstract concepts, the things we can't see with our eyes, and we can bring it into the physical realm to look at, manipulate, and actually start to pick apart a cell. My goal was to create a full model to pick apart and put back together.
So then when you do go ahead and put it back together, you're taking apart the individual, because these are individual organisms.
Correct.
So there are no other cells that go into constructing whatever that these are.
So say for this model, this is a cross section. So all of this space has extra stuff in there. I just didn't have the staining methods to have it show up. So if I printed those out individually and printed them at the same scale, I can fit them into this organism, and we can have a full model of this organism that we can take apart and put back together, just like operation.
And having that is, as you said, it's to kind of wrap your mind around what you're looking at, what you're dealing with when you're viewing these through a microscope.
Correct.
What does that help you do?
This helps the students who are visual learners grasp those concepts. Anybody can pick up a textbook and begin to read scientific speak. However, when you read my title, it was very, well, what is this giant title?
Absolutely.
The thing about it is we want to be able to create an environment that makes learning very, very simple. And this is one step or one way to do it. This is not the only method, but it is a proven method that if you have something in your hands that you can manipulate, you can begin to grasp those concepts.
You can bring in another sense to help you understand what you're dealing with.
Exactly.
You can look at it, you can see it, or you can see it, you can think about it, but when you have that ability to touch it and see it in a three-dimensional realm, then you have that much better understanding.
Correct.
Of it.
We also have other models where it is a digital model.
You mind if I pick one of these
No,
up and take a look at
absolutely.
it? So
Those guys are
they're
going to be
glued down?
stationary. Yep,
Okay.
there you go.
Now, why are those glued down and this one is
So
up to
during
move
my
around?
presentation, I wanted to actually show the students and the professors what a 3D model looks like when it is being printed. This is the base that actually gets put into the 3D printer.
so it prints
slides
it right
in.
onto this base?
Correct. And if you look, here's some imprints of those 3D models where they used to sit.
Okay, so when you took it off of there, it kind of left that imprint mark of where it was
Correct.
printed onto?
So you're going to see some tan material as well as some white support material on the bottom. That is, the support material is printed because if you were to print outside of the base of that model, that 3D printer wouldn't have anything to print on. So you need to have some support structure to actually create organisms such as this, where it has folds and it curves and there's concaves. It's a much more advanced 3D printer in
So
terms of
then when I
supporting
look at
itself.
this and those layers and kind of ridges that you can see on here, those are actually in the cell, so that's a full
Correct.
100% accurate depiction of what that cell looks
Correct.
like.
It is to scale, and I just scaled it down to a 3-inch model.
If you're looking at this in a microscope, how far in do you have to zoom to see this in its actual size?
These cells are typically smaller, a thousandth of a millimeter. So if you look at a millimeter on a ruler, it's that really, really small tick mark. We're going to take that one tick mark and divide it by 1,000.
So it's very, very, so obviously something that's too small to see to your own eye.
Exactly.
Well, that's about all the time we have, Vince. Thank you for coming in with these. This is very interesting. We're going to toss it to a package now by Aaron Bischoff about Oswego and BOCES and how they are joining together to have a club.